Okay, so sorry we just started videoing. The number 6 from 3.5 is right here. So you guys at home that are watching this, you might want to push pause. This was basically breaking it into two different equations that you made work together for 3.5. 3.5 number 7 is what we're on right now. Can you give me just like 10 minutes? Okay, thanks. All right, so now I'm going to look at number 7 where we are pretty much doing very similar to number 6. You've got two separate equations now, and we are making them work together. We solved for A in the first equation, plugged that in for the A in the second equation. And here's where we're at right now. We solved for R, but the total question wasn't asking for the R. They said, how many bacteria will there be after 7 hours? I gotta get like, I called it a B instead of a Y, but I gotta find my bacteria, not the R. Okay, so what I've got to do now is I'm going to take what this R equals, and I am going to sub that into this equation. Lots of arrows going on here. So if I sub that into this equation, I've got the 200 over e to the 3 times R. As messy as this R is, it actually kind of works out. Like the 3's divide out. And then I've got an e raised to a natural log, which bam, those are gone. So I end up with whatever 200 divided by 8 is, right? So let's do our 200 divided by, 200 divided by 8. What'd you get? What do we got, like 25? For the A. All right, so we've got the R, we've got the A. We can use those in the original problem, which again, this is what I had for my original problem right here. B equals the A, which in our case is 25, times e to the, we had e to the R times H. We found the R, messy R, but I found the R, times H. I called it a B and an H for a reason. We were talking about some bacteria after some number of hours. So it says, how many bacteria will there be after 7 hours? At this point, I can, because it says after 7 hours, I can put a 7 in for my hours. I can just put this in my calculator and get my final answer for the bacteria. So let's see here. 25 times e to the messy little natural log of 8 over 3 times, and I'm putting a 7 in for my H. All right, so for me, I got 3,200, and it says on here that is my correct answer, 3,200. All right, so similar to this one, like you had to have the 2 points that they gave you, you had to have them work together, but you did have an extra step as far as you had to then sub another number into the original equation. All right, so you guys at home, how are we doing on this one? Good, good. I think Nicole, this was your question, right? You good? Okay. All right, so let's see, another question we were looking at. I think Audrey, I did 28. Audrey, did you have another one? Or do you want me to just move on to the other ones that people were asking about? All right, 23 on the review. 23. So here is actually what we did in class. It's U substitution. So I don't know if you remember this, but you're basically holding the place of your e to the x with a u. So you can rewrite e to the x squared is e to the 2x, because your exponent rule is exponent raised to another exponent means you multiply those exponents. So e to the x raised to the 2 is e to the 2x. Oh, you meant 25. Okay, 25, not 23. All right, so let's look at this one. 25. So this one, you're trying to solve the equation. The problem is, though, they've got two separate natural logs. I need to condense it into a single natural log. So I will do the natural log of, and there's a big plus sign right here. Like I need to multiply the arguments. I need to do an x times an x plus 1. All right, so if I turn this into exponential form, this is the base of e, so it's like e to the third, equals this argument. I'm actually going to simplify this argument down. I'm going to distribute that x. So I get x squared plus x. All right, this is messy, right? In fact, I can't combine these. So the best I can do is I can subtract the e to the third over on the right side. So it's all equal to 0 on the left side. And as far as factoring, you're probably not going to know how to factor this. It's really messy. I would just use the quadratic formula. My c is really messy. It's a negative e to the third. See that c? Like I said, real messy over 2a. Okay. So I'm going to put this in my calculator. I'm going to do a negative 1 plus this messy square root, and then I'll try the negative 1 minus. So I'm not going to worry about multiplying by 1. I'm going to multiply by this negative e to the, there, e to the third, negative e to the third. All right, and that is supposed to all be over 2. Okay, so that kind of makes sense. If you look at my answer, that kind of makes sense where I got this 4.009. They wanted 3 decimal places. So that's where we got that one. And then if you do negative 1 minus, so I'm going to pretty much do my plus or minus. Minus that, and then over 2. It's this messy negative number, right? So if you check your answers, like if you plug this into the original problem, this negative causes the problem. In fact, I think when you plug this in your calculator, it's going to say error, like there's something wrong, because that's not in your domain. It doesn't work in this equation. So we had to cross off that answer and just go with the positive 4.009, which again, you can take that 4.009, you can plug it in here and make sure it actually all this ends up equaling 3 or not. So go ahead and check those answers. I do suggest on the test, especially, you guys check your answer. All right, so Audrey, you good with this one? You got it now? Okay, awesome. Okay, so where are we at now? That was, Audrey, let's look. Kislev, I think. Kislev, did you have another one, or do you want me to just move on? All right, so then, let's see. Alina, you were talking about, I think we did 21. We're gonna look at 26 though. It's actually right here. 26 on the review. So this one says to find the missing values assuming continuously compounded interest. So the fact that it's compounded continuously tells me about the Peirce equation. So that it told me what equation I'm using. The initial investment, this is like my P, I'm starting with 2,000. The annual interest rate, this gives me my R, but I do have to move the decimal over. I need 0.017 for the R. Okay, so Nicole, let me, hang on just a sec here. So I'm gonna do, let's see. How much time does it take to double it? And then what is your amount after 10 years? Okay, so let's put this in here. I've got the 200 for my P, sorry, 2,000 for the P. E to the 0.017 for the R. The T and the A though, they haven't given us anything until right here. They want their time to double. You gotta solve for the time to double what you started with. So instead of being at 2,000, you doubled it, you're ending with 4,000. So I have to solve for this T. I'm gonna move this down here a little bit. if I divide the 2000, I get 2 equals e to the 0.017t. I'm going to do the logarithmic form. I'm going to do natural log of 2 equals my exponent. And then I can divide by this 0.017 on both sides to get the t by itself. So I'm going to put this in my calculator here, the natural log of 2, and then I'll end my parentheses. That is all over the 0.017. All right, so that's where they got their whole 40.77. We rounded to 2 decimals, so there's the 40.77. All right, and then this last part here was amount after 10 years. That's actually kind of nice because if I just put my time of 10 years in here, now this is all on the right side of my equation, so I can actually just put it in my calculator at this point. That's kind of nice. Okay, so 2000 times e to the 0.017 times 10. All right. So that's how they got their 2,370.61 if I rounded to 2 decimals, 0.61. All right. Okay, gotcha. All right, so where am I at here? Yeah, no problem. Okay, so I think we're back to Nicole's, right? Actually, Zach just message me if you have certain problems you need me to go over. Okay, so Nicole, did you want me to go over this number 8, or did you want me to look at this other one that you told me, number 22? So Nicole, it looks like you posted a couple of them, whichever first. Okay, well, I think people asked number 8 in class. Let's talk about that one real quick. So I think a lot of people had that question. This is 8 on your 3.5 homework. Oops. Just kidding. Where's the other one? There we go. Okay. So number 8 right here. They gave you this equation. So you probably have different numbers in the equation, but very similar type of equation. So this is what they gave me, and then they said, okay, first of all, this problem, I wouldn't even do part A first. I think I would do B and C first. So your part B says to complete the model by solving for K. So I got to solve for this K, and what they told me was with T equals 0 corresponds to 2010, and then in 2013, you end up with 300,000. So what I end up with is the S. I'm going to put a 300,000 there. Equals my 500,000 over 1 plus 0.1. This 300,000 happened in 2013, where your 2010 was times 0. Your 2013 is like time 3. I'm going to put a 3 in for my T. It's like 3 years later. Okay, so the only variable I have now is the K. So let's see here. I'm going to take this whole C down here a bit. I'm going to take this whole denominator and I'm going to multiply it to the other side. All right, and then I'm going to divide that whole thing over, which it's like 5/3 there. Which at this point, I will then subtract 1 on both sides. So I get a 0.1 e to the 3k equals, let's see, I'm at 2/3 now. I'm going to divide by my 0.1 on both sides. Okay. Get rid of that c real quick. Okay, so now I'm at, if you want the fraction, I'm at like 20/3, if you do it that way. And then, Yeah, I got my 3 because it says you time 0 was in 2010. So if we went up to 2013, yeah, it was 3 years later. So that's why my t was a 3. Okay, good question. So I'm solving for the k here. Because I got the e, the exponential, I guess, I got it by itself, I can now turn it into a logarithmic form. I can do natural log of this 20 over 3 equals the exponent, which if I divide by 3 on both sides, I can now just put the whole thing in the calculator. So I'm going to do my natural log of 20/3. I'm going to do it all over 3 to get my messy k value, which was 0.632, blah, blah, blah. Mine sent to round to 3 decimals, so we got a 0.632 for the k. All right, that was part B. Part C, it says, use the model to estimate sales in 2021. So in 2021, where am I at here? Okay, so 2021 from 2010, that is like 11 years. 21 is 11 past 10. Okay, so I'm going to, use my little equation up here. So we already found, that's what I want to do B first. I just found what the k equals. So I'm going to put that what was it, 0.632 in my problem. Yours might be a little different, but I put that 0.632 in for the k. And they want you to solve for the s when you are now, what, 11 years later? So I'm going to put an 11 in for the t. All right, so at this point, I can do kind of nice on part C. I can just put it in my calculator. I do need to use some parentheses. I have to divide by this entire thing. All right, and 0.632 for the k, and then 11 for the t. All right, so this is what I ended up with. They wanted me to round to the nearest whole number in this case, so I went with 4,738. All right, the last problem was just asking, it wasn't even something to solve. The last part was just said, compare your results like to part A. Part A, honestly, this is the same answer for part A. It's still that same, was it 4,738, the nearest whole number. I have the same answer for A and C, whether you estimated or got it exactly. There you go. All right, which it was similar. So your part D, I think you had to say it is similar to what you started with. Similar to the graph. Okay, so Nicole, are you good with this? All right, okay. So then we've got a couple other questions here, and we've got only like 20 minutes left. Okay, so Zach, are you looking at, oh, you gotta be looking at the review then, huh? Not the.
Yeah.
Okay. So Zach, here is 16. Actually, we already did this one. So this one, you had to expand it because it was all divided. It was 8 divided by this big old square root. I expanded it with subtraction. And then I used the exponent rule to bring that exponent of 1/2. Now you had to recognize that any square root can be written with an exponent of 1/2. So I think that may have been where people were getting stuck on it. Rewrite your square root as the exponent of 1/2, and then I can use that other exponent rule where you bring the exponent down in front. So that's how they got this answer.
Yeah. I mean, I got close to there. I just forgot the 1/2.
Yeah, I think that's what a lot of people were doing. Okay, and then, oh, Nicole, you're asking about the last one we were talking about. You're talking about this one?
What?
I'm asking Nicole if this is the one that she was talking about. She didn't take a picture. Yeah, you got that? All right, so there you go. All right, so did you already get it? Did you already get your picture? All right, cool. So then, let's see where I'm at now. Did that one. Da, 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 da. All right, Audrey, do you have another one?
Sorry, could you go over 13 maybe?
All right, on the review?
Yeah, on the review.
Alrighty, so I do have to, on 13, I have to do like what I was talking to Zach about, where you have to take your square root and write it as an exponent of 1/2. In fact, what that means is my e to the 1/2 is in the denominator. If I want to put it up in the numerator, I can say it's e to the -1/2. So we kind of have to know our exponent rules. And the whole reason I use those exponent rules is because now I have some natural log of some e, which again, those are inverses, so those are gone. All I have left is the -1/2. But yeah, we had to use a lot of exponent rules on that one. All right, no problem. All right, so then Kislev, is there something else you got? $27. All right, 27, I was kind of writing all over the place from 26, so I'm gonna erase this real quick. Okay. Okay, so for 27, determine that the principal P that must be invested at a rate of 8% compounded monthly. Okay, not compounded continuously, so I'm not gonna use the PERT. It's compounded monthly. I need the equation with the N in it, so my N can be a 12. All right, so that $500,000 will be available for retirement in 15 years. All right, so my initial amount, how much I start with, like P, I don't know what that is. I do know that I want to end up with the 500,000. I don't know what I start with. I know what I'm ending up with. And then I've got 1 plus my interest rate, not just an 8, but a 0.08. Oops. All right, 0.08 over the N, so over the 12, raised to the NT. N is still a 12, and T is my time. We were talking about 15 years here. All right, so just a reminder, this was my equation that I was just using. Okay, but I have to solve for the P. So the nice thing is I can actually put this in my calculator and get whatever this number is that's multiplied by the P, and then I'll divide it over to the other side. So let's see here. In parentheses, I get my 1 plus 0.08 over 12. Okay, and that is all raised to the 12 times 15. So as messy as this is, the calculator will actually get all that for me. All right, that messy 3.306, yada, yada. I need to divide that over to the other side. So I'm gonna do my 500,000 divided by this messy answer. Okay, so here's what I got, 151,198.03. If I'm talking money, I'm probably gonna round to the nearest cent, the second decimal there. So 0.03. So that's kind of how they got this answer right here. All righty.
Actually, sorry, can you scroll to the right a little bit?
Yeah, there you go. And Kislev, are you okay with this?
So I tried it with, mine had different numbers and I tried
Okay.
it and I also got it wrong.
Okay, so what all is different on this?
So the one I have, the rate is 5%.
5%, is that what you said?
Yeah.
Okay, so you're gonna have a 0.05. Is it compounded monthly still?
Yes. Oh, I
Okay.
see what I did. I got confused and I did 15 years instead of what my problem says.
Oh, gotcha. Okay,
Okay.
you're good.
Never mind. Thank you.
Uh-huh. All right, let's see what else we got here. So Elena, Which one's our next one, Alina? Is it the 27? Is that our next one? Oh no, we just did 27. So what's our next one, Alina? All right, awesome. And then I think, Zach, you were asking about the 21.
And yeah, 22 if we can.
So I actually already did the 21. So I'll let you look at that while I do the 22 as well. So the 22, I am going to turn this into a logarithm first. I will do a log base 4. The 4 was the base of my exponential, so I made that the base of my logarithm. So I'm doing log base 4 of 331 equals my exponent. The whole point of a logarithm is to solve for the exponent. All right, so at this point, it's going to be really messy, but I can solve for the x. I can add 9 on both sides. This 9 is not in a logarithm, so I have to leave it outside of this. Maybe I'll put it at the beginning, but I cannot put the 9 in the logarithm. And then I will divide by -1 on both sides to get my x by itself. So again, messy, but I'm just going to put it in my calculator. All right, so 9 plus the log. All right, log base 4. Let's do the common log, or sorry, not the common log. I'm going to do the change of base formula into common logs. So I'll do, instead of log base 4 of 331, I'm going to do log base 10 of 331 over, again, a log base 10 of 4. It's my change of base formula. Okay, and then it was divided by a -1, so basically change the sign into a negative number. So that's how they got this negative 13.185. Okay, so you good with that, Zachary?
Hold on.
Okay. So you can turn exponentials into exponential equations, I should say. You can turn an exponential equation usually into a logarithmic equation, and back and forth. I can turn a logarithmic equation into an exponential equation. Nice. Okay. So then we're going down to 23, it looks like. There we go. All right, we got about 9 minutes left here. What else we got? Yeah, no problem, Audrey. All right, I'm gonna